Rational Approximations. Essential question. How do you approximate a square root without using a calculator? So this lesson is all going to be about approximating and estimating decimals for square roots. Please do not use a calculator for this lesson. Alright, as review, I would like you to name the first 10 perfect squares. I'm not going to write them out because at this point you should be able to do it on your own, but I'll get you started. 1 squared is 1, 2 squared is 4, 3 squared is 9, go all the way up to 10. You'll want to use that list for the lesson today. Find a reasonable decimal approximation for each of these square roots. So let's start with the square root of 41. So the two perfect squares that fall on both sides of the square root of 41 are the square root of 36 and the square root of 49. Now the square root of 36 is 6, the square root of 49 is 7. So that means my decimal has to be somewhere between 6 and 7 because 41 is in the middle of 36 and 49. Now to get from 36 to 41, it's 5 away. To get from 41 to 49, it's 8 away. So that means that the square root of 41 is going to be closer to 6 than it is 7 because it's only 5 away rather than 8 away. Since it's 5 away, I don't want something super close to 6, but it's also not quite in the middle either. If it were in the middle, then the 5 and 8 would be closer together. So there are really a couple options you could have for an answer on this one. I think 6.2 or 6.3 would both work. Again, we're approximating, so it doesn't have to be exact. All right, the next one is the square root of 13. So the two perfect squares that fall on both sides of 13 are 9 and 16. Square root of 9 is 3. Square root of 16 is 4. So that means that our decimal is going to be somewhere between 3 and 4. To get from 9 to 13, it's 4. To get from 13 to 16, it's 3. So this one is going to be closer to 4 than it is 3. But you'll notice since 1 is 4, 1 is 3, it's really going to be close to the middle. When those numbers are only 1 away from each other, it's close to the middle. So the middle of 3 and 4 is 3.5, but we need it to be a little closer to 4 than 3 because this 3 is smaller than that 4. So something closer to 4, but just a little bit bigger than halfway would be about 3.6. This starts out tricky, but I think that it makes more sense as you go because you'll do it a bunch of times in the lesson. Square root of 70, the two nice square roots are the square root of 64 and the square root of 81, which is 8 and 9. From 64 to 70, it's 6, and from 70 to 81, it's 11. So 6 is smaller than 11, so that means my decimal is going to be closer to 8 than it is 9. Now, again, we could choose a couple options. I think 8.2 would work, 8.3, maybe even 8.4. We'll say 8.3 this time. Again, we're approximating, so it doesn't have to be exact. Alright, which of the following is slightly greater than the square root of 53? Now, if you look at our answer choices here, they're all as fractions. But today we are approximating using decimals. So the first thing I'm going to do is turn all of these fractions into decimals to help me solve this problem. So 7 and 1/5, that one you might not know on your own. So let's skip to 7 and 2/3. By this point, you should have those memorized. 2/3 is 0.6 repeating, 1/3 is 0.3 repeating. 3/10, anything over 10, you just take the top number, so it'd be 7.3. Now 1/5, we're going to have to divide that the long way. So my numerator, the nerd, goes in the house, the denominator, the dog, stays outside the house. 5 can't go into 1, but it can go into 10 if I add a 0 twice. So my answer is 0.2, so this is 7.2. So now I've got 3 answer choices. So let's figure out what the square root of 53 should be. So the two nice square roots on both sides of 53 are 49 and 64, which would be 7 and 8. 49 to 53 is 4 spots. 53 to 64 is 11 spots. So that means it's going to be closer to 7 than it is 8. Now this one's a little tricky because we have two answers that are closer to 7. We have this one and we have this one. I think we can eliminate this one because that's closer to 8 and we need it closer to 7. Now what you can do on a problem like this where it's very close is you can take this 4 and 11 and divide it. So 4 divided by 11, 11 can't go into 4 but it can go into 43 times. Bring down a 0, 11 can go into 76 times, so 66, and then that would give me a 4. So then I'd have 40, 11 could go into 40 3 times. So the answer I think that we should choose for this, and if we have 0.363, would be this one. Because 7.3 would be closest to 7.363. So if it's one where there's answers choices that are really close, take the two numbers, the two differences, and divide. Alright, find the approximate value, 8 plus the square root of 22. So first let's find the square root of 22, and then we've got to add 8 onto it. So 16 and 25 are the two nice square roots on both sides, so 4 and 5. This one is 6 away, this one is 3 away. So that means my answer is going to be closer to 5 than it is 3. So let's approximate it, let's say 4.7. But keep in mind that's not our answer, we have to add on 8 to that. So 8 plus 4.7 is 12.7. You could have had 4.6, 4.8, again we're approximating, so all of those would have worked. Okay, so a problem like this looks a little different. When we have two square roots, what I want you to look at is their bases. I call these their bases, what's underneath the square root sign. If both of the bases are the same, leave it the same. So they're both 12, so we'll leave it at 12. Then we're going to take our 3 and our 5 and we're going to add them because there's a plus sign in the middle. So 8 square root 12. The operation happening between 8 and the square root of 12 is multiplication. So let's figure out what the square root of 12 would be as a decimal. So we've got the square root of 9 and the square root of 16 on both sides, so 3 and 4. To get from 9 to 12 is 3. To get from 12 to 16 is 4. Now since 3 and 4 are just one away from each other, it's going to be close to the middle, so close to 3.5. But it's going to be a little closer to 3 than it is 4, so 1 closer to 3 than 4 from 3.5 would be 3.4. So now I have to take 8 and multiply it by 3.4. So remember when you're doing long multiplication, you always want the number with more digits on top, fewer digits on the bottom. 4 times 8 is 32. 3 times 8 is 24, plus 3 is 27. Since this is 1 over, we move it 1 over. So my answer is 27.2. Alright, 9 root 23 minus 2 root 23. Again, I'm going to look at my bases. So my bases are the same. So I'm going to leave them as the same, 23. Then I'm going to take the 9 and 2 out in front and subtract them because of the minus sign. So this is like 7 times the square root of 23. So let's figure out what the square root of 23 would be. I'll do that over here. So the two nice square roots on both sides would be 25 and 16, which is 4 and 5. To go from 16 to 23, it's 7. And from 23 to 25 is just 2. So that means since it's only 2, my answer is going to be pretty close to 5. So I would say either 4.8 or 4.9. Either of those would be fine. So 7 times 4.8. Put the 4.8 on top and the 7 on bottom. 8 times 7 is 56. 4 times 7 is 28. Plus 5 is 33. Move my decimal 1 spot. So 33.6. 2 more. Alright, so we have 9 square root 55 and divided by 3 square root 11. Now this time our bases, the square root of 55 and the square root of 11, are not the same. So that means I have to do the operation in the problem, which is division. So 55 divided by 11 is 5. And then I have to do the same operation with the 9 and 3. 9 divided by 3 is 3. So 3 times the square root of 5, let's approximate the square root of 5. So square root of 4 and square root of 9, which is 2 and 3. 1 away, 4 away. Since it's only 1 away, my answer is going to be really close to 2, so we'll say 2.1. So 2.1 times 3 is 6.8. And the last one again, our bases are different on this one. So the operation happening between two parentheses is multiplication. So 2 times 10 gives me 20. And then 5 times 3 gives me 15.
There's a check. Thank you. Doesn't fill out.
Okay, so then we are going to approximate the square root of 20. So we've got 16 and 25. So 4 and 5. 16 to 20 is 4. 20 to 25 is 5. So that means it's going to be right in the middle of 4 and 5. So that'd be 4.5, but it's a little bit closer to 4. So we'll say 4.4. So we're going to take 15 and times it by 4.4. 5 times 4 is 20. 4 times 1 is 4. 5, 6. Bring down the 0. 4 times 5 is 20. 4 times 1 is 4. 5, 6. So we have 6, 6, and 0. So my answer is 66. Summary. The homework for this lesson is the Rational Approximations package.